Welcome dear students. Now let us continue with the 36th question. Now question says ABCD is a cyclic quadrilateral in which AB is parallel to DC and AB is the diameter of the circle. Okay, so this is my circle, alright, where AB is parallel to DC. So that's all is given and AB is the diameter. That means this line AB is my diameter of the circle. Alright, it is given that BED is equals to 65, right? So this is given to 65 degree and we need to calculate DAB. So DAB means this angle, alright, and another one is BDC. So we need to calculate BDC, which is given out here, alright. So let's begin with the sum here, alright. So it is given that DAB and BED are in the same segment of the circle. Now let's check whether they are true or not. Okay, so let me call this BD to be a line which divides the circle into two segments. One is this one and another is this smaller one. Alright, now in this bigger segment we see that this D and B is making two angles, that is DAB and another is DEB. Alright, so these two are angles in the same segment, right? So that's why we say that these two angles will be equal, because angles in the same segment will be equal. Okay, and since this is 65, this is also going to be 65. All right, so I have found it, my first answer, that is DAB. So angle DAB is equals to how much? It is equals to 65 degree out here. Okay, now let us see how to calculate angle BDC. Now let us see where is BDC. So we have got BDC out here, right? Okay, so now we know that DC is given to be parallel to AB. So DC is parallel to AB. Alright. Now obviously BDC, that is BDC, that is this angle will be equals to this angle, right? That is DBA. Why? Because they are alternate angles. Alright. Okay, now let us have a look at triangle ABD. So in triangle ABD, now we know that AB is diameter. Now if AB is diameter, then obviously this angle has to be how much? This has to be 90 degree, because this is the angle in a semicircle. Alright, so angle ADB turns out to be 90 degree. Okay, now ADB is 90 degree, means if this is 90 degree, then sum of this, that is DAB, and sum of this. Okay, alright, this is 90 degree, then sum of this and this angle has to be also 90 degree, because in this triangle sum of the interior angles will be 180. This is already 90, so that's why sum of these two has to be 90 degree. So that's what is written out here. Okay, so this means DAB. Okay, so DAB is already found out to be 65. Now what is DBA? So DBA is this angle, so this turns out to be how much? This turns out to be 25 degree. So that means this angle is 25 degree out here. Okay, so if this is 25, then this also has to be 25, because they are alternate angle according to this. Alright, and we are asked to find BDC, right? So BDC will be equals to DBA and DBA is equals to 25. So that's why I'll have angle BDC equals to 25 degree. Alright, so pause the video to note down. Okay, now let's have a look at this particular question. So in this question, in the given figure, AB is the diameter. So again, AB is diameter. Okay, and ED is a chord parallel to AB. So ED is parallel to AB. Okay, and angle EAB is equals to 63 degree. That is, this is given to be 63 degree. Now you need to calculate what is EBA. Okay, so EBA is this one, right? So we need to calculate this angle and we need to calculate BCD, that is this angle. Alright, so let us see how to calculate this. Okay, so what are the things that we can see from the diagram? Let us observe first. So these two are parallel and this is a chord, so that's why this angle and this angle will be equal to each other, because they are alternate angles. Okay, so AOB is the diameter. Now if this is my diameter, then obviously this has to be, again, this has to be 90 degree. Okay, so angle AEB is 90 degree, because this is angle in a semicircle. Okay, now in this triangle, as I said, if this is 90 degree, then sum of this angle and this angle has to be again 90 degree. So that's what is written out here. So angle EAB plus EBA will be equals to 90 degree. Now we know that angle EAB is 63 degree. So instead of this I am writing 63. Alright, so 63 plus EBA gives me 90 degree, and from here EBA turns out to be 27 degree. Alright, so we have found it, our angle EBA out here. Okay, now our job is to find angle BCD now. Okay, so let's see how to find angle BCD, that is this angle. Alright, so it is already given that this happens, right? Okay, so ED is parallel to AB. Now as I said earlier, there are alternate angles here. Okay, so alternate angle, that is DEB and EBA, both will be equal, and we know that EB is 27, so that's why this angle should also be 27 degree. Okay, now there is a cyclic quadrilateral also, if you see here, and which is that cyclic quadrilateral? That is this. Okay, so that is EBCD, because they are lying exactly in the circumference. Now you might say we have got A also in the circumference, but A is not forming any cyclic quadrilateral if you see here. Okay, for example ABCDEA. So if you take this is not a quadrilateral because we have got 5 sides, 1 2 3 4 5, right? Okay, so the only cyclic quadrilateral here is EBCD. Okay, so in the cyclic quadrilateral, what happens is sum of this plus this, because they are lying opposite, angle E and angle C, both of them are lying in the opposite sides, so sum of them has to be exactly 180 degree. All right, so that's what is written out here, and we know that angle DEB is how much? 27, so it is written 27 instead of DEB. Now from here if I calculate BCD, so this turns out to be 153 degrees. So my answer for this will be 153 degree. So pause the video to note down. Okay, now let us have a look at the 38th question. So question says, in the following figure, AB is the diameter of the circle with center O. Right, DO is parallel to CB, right, and angle DCB is given to be 120 degree. We need to calculate DAB, DBA, DBC, ADC. All right, and later on we need to show that triangle AOD, that is this triangle, is an equilateral triangle. Okay, so let us go one by one. Now let us see how to go for DAB. So which is DAB? Let us see. So DAB means this angle, right? So we need to calculate this. Now let us have a look at the points A, B, C and D. All of them lie exactly in the circumference, so that's why I can say that ABCD is a cyclic quadrilateral. Now one of the very important property of cyclic quadrilateral says that sum of the opposite angles, that means angle A plus angle C, has to be equals to 180 degree. All right, so we know the value of C, so that's why we will be able to find the value of angle A. All right, so we have number 1, that is angle ABCD is a cyclic quadrilateral, that means angle C plus angle A, all right, will be equals to 180 degree. Now what is DCB given? So DCB is given to 120 degree, right? So instead of this I have written 120, so from here DAB turns out to be 60 degree. So our first answer, that is DAB, so this angle turns out to be 60 degree. Now our next thing is angle DBA. So let us see where is DBA. So DBA is this one, right? So this angle has to be found out. All right, now we know that this AB is the diameter, that means if AB is the diameter, then this angle, that is ABD, has to be 90 degree because it is the angle in a semicircle. Okay, so angle ADB is 90 degree. Now if this is 90 degree, then sum of this and this has to be again 90 degree. All right, so this plus this will be 90 degree out here. All right, so we know the value of DAB, so DAB turned out to be 60 degree out here, right? So instead of DAB I am writing 60 degree, and from here DBA turns out to be 30 degree. That means this angle is equal to how much? 30 degree. All right, so we don't have space here, you may pause the video to note down. Okay, let us continue with the next part of the question, that is to calculate angle DBC. Okay, so to calculate DBC, let us check where is DBC. So DBC is this angle. Alright, so before we look at this angle, let us see what is happening in this triangle, because we see that these two lines are parallel, so that's why this angle and this angle has to be alternate. Alright, now in order to get this, let us have a look at this angle. Alright, now this and this both are radius, right? So that's why OD and OB are equal in this case. Okay, so in triangle OBD we have OB equals to OD. Now if these two are equal, then this triangle is an isosceles triangle. Alright, now the angles, this one and this one, they will also be equal here. So that's why I'm written ODB. So ODB is this angle and OBD will be equal to each other, because this is isosceles triangle. Alright, and we have already found how much is this, and this was found out to be exactly 30 degree, right? So that's why this turns to be 30 degree. Alright, that is from question number 2. Alright, that's why I have got ODB, that is this angle, also equals to 30 degree. Okay, now we know that DO, okay, DO is parallel to CB. That's all is given from here, from the question. Okay, so that's why I say that these two angles, that is this angle and this angle, are alternate angles, so that's why they are equal to each other. Okay, and we know that what is ODB? ODB is equals to 30 degree. So that's why angle DBC will also be 30 degree. Alright, so my third answer was angle DBC equals to 30 degree. Okay, now let us go to the fourth question, that is ADC. So ADC lies out here. Alright, now in order to calculate ADC, let us calculate ABC, that is this full angle. Because if we are able to calculate this angle, then we can again make use of cyclic property, because angle B plus this angle D, that is ADC, will be equals to 180 degrees. So for that we will first calculate angle ABC. Okay, so we know that ABD, so ABD means this angle, right? So this angle plus this angle gives me angle ABC, right? So that's what is done out here. Alright, so ABD plus DBC, ABD plus DBC will be equals to 30 plus 30, because both are 30. ABD is 30, DBC is also 30. But when you add ABD and DBC, you will get angle ABC. So that's why this angle ABC will be 60 degree. Alright, so 30 plus 30 is 60. Now this full angle is 60. So that's why using cyclic property, so we have ADC plus ABC will be equals to 180 degree. So let's put the value of angle ABC. So from here ADC turns out to be 120 degree. So we are done with the last part as well. Now let us see the final part, that is triangle AOD is an equilateral triangle. Okay, so in triangle AOD, so let us see what is happening in triangle AOD. So we know that OA and OD will be equal. OA and OD will be equal because they are radii of the same circle. Okay, now if they are radii of the same circle, next thing will be this angle and this angle will be equal to each other. Yes or no? Yes, definitely, because this was already found out to be 60 degree. So that's why this will also be 60 degree. Okay, so that's what is written out here. Okay, now if this is 60, then this is also 60, then obviously this last part will have to be 60 degree, because 60 plus 60 is 120, and how much ever is left, that will be this value, that is 60. Alright, so clearly we see that all the angles are 60 degree, and in equilateral triangle all the interior angles will be 60 degree. Alright, so since all the angles are 60 here, so that's why I say triangle AOD is an equilateral triangle. So pause the video to note down. Okay, let's have a look at the next question. So this question is going to be a bit tricky for you. Alright, so please pay attention to this question very carefully. Now in the given figure, I is the in-center of triangle ABC. So I is the in-center of ABC, means this line is there, right? So this I is being formed by the intersection of three bisectors. Okay, so whenever we take the bisectors of each angle of a triangle, for example, in angle ABC, it is given that BI, right? So this BI is the bisector of angle ABC. That means angle ABI. So this angle and this angle both will be equal because BI has bisected the angle. Alright. Similarly, from here also if I draw a line, okay, so this line divides angle BAC. Alright. And similarly, if I draw from C a line like this, then this line will be the bisector of ACB angle. Alright, so that is the meaning of incenter. So incenter I is the point of intersection of three angular bisectors of a triangle. Alright, now it is given that BI when produced, so when it is produced, it is meeting the circumcircle. Circumcircle means the circle which touches all the vertices of a triangle. Alright, so all the vertices of a triangle is lying in the circumference. So this kind of circle is called circumcircle. So this BI when it is produced meets the circumcircle at point D. Alright, okay, so it is given that BAC, so this angle is given to be 55 degree, and ACB, that is this angle is given to be, so ACB, that is this angle is given to be 65 degree. So we need to calculate these four different angles. Alright, so before we do that, let me do some construction out here. Okay, so let me join these points. Alright, so the construction says join AD, DC, AI and CI. Okay, now in triangle ABC, so in triangle ABC, remember this angle and this angle is given, so definitely we will be able to find this angle, that is angle ABC, right? So angle ABC will be equals to 180 minus this angle and minus this angle. All right, so BAC is 55 and ACB is 65. So if I put the value, then angle ABC turns out to be 60 degree. As I said earlier, IB, so this is the bisector of angle ABC, right? So that's why I must say that ABD and CBD both will be equal, and both of them will be exactly equal to each other. All right, so I can say ABD will be equals to half, because it is a bisector, right? So half of ABC, so that's what is written, and ABC is 60, so that's why half of 60 is 30. So ABD, that is this angle, turns out to be 30 degree. Okay, now let us move on to the next part. Okay, so we can say DC and ABD, DCA and ABD will be equal, and they will be equal to 30 degree. Why? Because they are angle in the same segment. Let us check whether they are really angle in the same segment or not. All right, now let us have a look at DCA. So DCA means this angle, right? So DCA means this angle, and ABD means this angle. So that means if I call this line AD, then in this segment, okay, in this bigger segment, this AD is forming two angles, that is ABD and DCA, right? So we know that angles in the same segment will be equal to each other, so that's why this angle and this angle will be equal, and we already know that this is how much? 30 degree, right? So that's why my value for DCA will also be 30 degree. So we have founded our first answer. Now similarly, let us see what is DAC. So DAC is this angle. All right, now let us see the line CD. Okay, so CD in this segment, okay, in this segment forms two angles. One is CBD, that is this angle CBD, and another is DAC, right? So that means this angle and this angle has to be equal, right? And do we know this? Yes, definitely, because we know that BI is the bisector, so that means this is also 30, this is also 30, right? So that's why DAC, that is this angle and this angle will be equal, and they will be equal to 30 degree because they are also angle in the same segment. All right, okay, now next is angle ACI. All right, now we know that this AI also bisector, CI is also bisector, as I said in the beginning itself. All right, so similarly ACI can be written as half of ACB, right? Half of ACB, because CI is the bisector of ACB. All right, and how much is ACB? So ACB is equals to 65. So what is the half of 65? So half of 65 is 32.5 degree. So that means ACI, that is this angle, is 32.5 degree, and we are asked to find DCI, right? So DCI is this one. All right, so DCI can be found out using ACI plus this one, that is DCA. All right, so DCI will be DCA plus ACI, which is 30 plus 32.5, which is 62.5. all right, so my value for angle DCI turns out to be 62.5 degree. Okay, now let us move on to the last part, that is AIC. Okay, so AIC means we have to find how much is this. I'm sorry, AIC means we have to find how much is this angle. So let us see how to find this. Okay, so do we know this? Yes, we know this. Do we know this? That is CIA? No, we don't know this. So let us find how much is that. Okay, so IAC. Now we know that AI is also a bisector of BAC, isn't it? Now if AI is the bisector, then IAC will be half of this angle, right? So that's why I have written IAC is half of BAC. And how much is BAC? BAC is 55 degree. All right, and half of 55 degree is nothing but 27.5 degree. All right, okay, so that's why AIC can be written as 180 degree, because in this triangle we have sum of the interior angles equals to 180 degree. So that's why this angle itself will be equals to 180 minus this minus this. So that's what is written out here. So let us put the values. So IAC is 27.5, right? IAC turned out to be 27.5, and ICA, that is this angle, is 32.5. So just simplify this, you'll get the value to be 120 degree. That means this angle is how much? 120 degree. All right, so pause the video to note down. Okay, now let us have a look at the next question. So question says a triangle ABC is inscribed in a circle. So it's kind of a similar question to 39. All right, so let's have a look at this again. So triangle ABC is inscribed in a circle, okay, and the bisector of BAC, okay, so bisector of BAC is at P. Okay, so this means AP is the bisector of BAC. All right, similarly the bisector of ABC is BQ, and similarly the bisector of AC is CR. Okay, so ACB is CR. Okay, so we need to prove that these quantities happen out here. All right, now let us see how it happens. So before that we will do some construction, that is we will join PQ and PR as it is shown in the figure. Okay, now if we see here carefully in this diagram, ABQ, so ABQ is ABQ, that means this angle. Okay, so this angle, and APQ, that is this angle. So this angle and this angle, both of them are in the same segment of the circle, right? So if you consider AQ, then in this segment for AQ, ABQ and APQ are in the same segment of the circle. That means this and this will be equal to each other. All right, now we know that ABQ can be written as half of ABC because BQ is the bisector of ABC. So that's why ABQ can be written as half of ABC. All right, now in this case I am substituting this ABQ with half of ABC. So if I do that, then this becomes half of ABC equals to angle APQ. All right, so let us take this 2 out here. So we'll get angle ABC equals to 2 times APQ, which is my first answer. All right, so we have got our first answer. Let me call this as equation 1. All right, now the second one is also similar. So in the second one we are interested with APR. All right, so let us see where is APR. So APR is here. Okay, so APR means this AR is there, right? So AR is forming 2 different angles out here. If you see here carefully, in the segment. All right, so one is APR, another is ACR, so both of them will be equal. All right, so APR and ACR are in the same segment of the circle, so that's why they will be equal to each other. All right, now we need to remove this ACR. All right, so ACR can be written as half of ACB, isn't it? So we have ACR equals to half of ACB because CR is the bisector of angle ACB. Okay, now let us do the cross multiplication. So if I do that, then I'll get, okay, let me first replace the value. Okay, so instead of this ACR, I'm writing half of ABC. So half of ABC is equals to APR. So do the cross multiplication, you'll get angle ACB equals to 2 times APR. So that's what we need to prove in the second part. So let me call this as 2. All right, so we pause the video to note down. We'll see the third part in the next slide. Okay, so let me add 1 into this one and this one. So in the left hand side we have got this, and in the right hand side we have got this. Now we see that 2 is common out here, so let me take 2 common. All right, now we have APQ plus APR, that is APQ, that is this angle, and APR is this angle. Okay, so this angle plus this angle will be equals to QPR, right? So that's why instead of this I am writing QPR. All right, okay, now from here what we can say is 2 QPR will be equals to angle ABC plus angle ACB. All right, now in other way, let me take this 2 there, so we'll get half here. So we have equation number 3 out here. All right, now let us observe this triangle carefully. So observe triangle ABC. So in triangle ABC, sum of the interior angles will be equals to 180 degree. All right, so from here we need the value of only this one. All right, so ABC and ACB is kept here, BAC is kept this way. All right, so instead of this I am using this in equation number 3, so I have written equation number 4 for this. Okay, so from 3 and 4, that means if I substitute this by this one, then I can write this as QPR as 180 minus angle BAC and open the bracket, so this becomes 90 minus half angle ABC. So that's what we need to prove out here, right? So you may pause the video to note down. Okay, so let's have a look at this question. So in this question, the relationship between x, y and z is given out here. Okay, so this is kind of our ratio and proportion chapter. All right, so this is a given figure, so let us observe this figure very carefully. So basically here ABCD is a cyclic quadrilateral, right? Okay, so we have from this diagram, this one and this angle will be equal to each other because there is a figure of the form x, and whenever we see x, then we have to search for vertically opposite angles. So this one and this one are vertically opposite angles and they are going to be equal to each other. All right, now in this cyclic quadrilateral we will find how much is this angle. Okay, so this angle, so if you observe this triangle CDQ, okay, so this angle, that is CDA, acts like your exterior angle, and we know that exterior angle will be equals to sum of the opposite interior angles, that is x plus z. All right, so that's what I'm going to do out here. Okay, so before that let me take this to be k. So from here x by 3 will be equals to k, so x will be 3k, y will be 4k, and z will be 5k, which you have already seen how to get through the chapter of ratio and proportion. All right, okay, so in triangle CDQ, as I said, in this triangle, exterior angle ADC, that is this angle, will be equals to sum of the opposite interior angle, that is x plus z. All right, now in this case also this will be my x because they are vertically opposite angles. So that's why in triangle BPC, that is this triangle, we have BCP, that is this angle, will be equals to DCQ, which is x. Okay, because they are vertically opposite angle. So that's why I can say this exterior angle ABC will be sum of this and this, that is y plus x. All right, let me call this as 1 and let me call this as equation 2. Okay, so since this is a cyclic quadrilateral, sum of this and this will be equals to 180 degree. All right, so let me add these two. So we have, if I add these two, we'll have this plus this, which is written out here, will be equals to ADC plus ABC. All right, and we know that ADC plus ABC, that is this angle plus this angle, will be how much? 180 degree, because they are opposite angles of a cyclic quadrilateral. All right, so instead of this I am writing 180. So from here x plus x is 2x, so 2x plus y plus z will be equals to 180 degree. Okay, now we know that what is x? X is 3k, y is 4k, and z is 5k. So let me put the values, all right, and simplify it. So after simplifying, you will get k equals to 12 degree from here. Okay, so after getting k, or at last we need to find the value of x, y, and z. So we will put the value of k here in this, okay, in order to get x, y, and z. So from here we have x equals to 3k, so k is 12, so 3 into 12 is 36. Similarly, y turns out to be 48 and z turns out to be 60 degree. So my final answer for this particular question will be this one. So you may pause the video to note down. Okay, now let's move on to the last question for the day. So question says, in the given figure, AB, AC and CD are equal and ADC is given to be 38 degree. So we need to calculate angle ABC, that is this angle, and we need to calculate BEC, that is BEC. So let me see first angle ABC. Okay, so here BE is joined. Okay, so BE is joined, that will be done later. Okay, so BE is joined will be used in this case, so I'll show you in the next case. So in triangle ACD, so ACD is this one. So this and this are given to be equal. So what kind of triangle is this? This is again isosceles triangle. So in isosceles triangle, this angle and this angle will be equal. That is, angle CAD will be equals to CDA, which is 38 degree. Alright, so this is 38, this is also 38 here. Now exterior ACB, that is this angle, okay, ACB will be equals to, in this triangle, if this is my exterior, then this exterior will be sum of the opposite interior, that is 38 plus 38, right? So this turns out to be 76 degree. Okay, so this angle is how much? 76 degree. Now if you see this triangle ABC, this angle and this side and this side both are equal, right? So it is given. So that means this is also isosceles triangle. So if this is 76, this also has to be 76. Okay, because this is isosceles triangle. So that's why angle ABC is also 76 degree. So we have found it our first answer. Now as I said, for the second case, BEC, we need to join BE. So let me join BE out here. Okay, so we are asked to calculate BEC, that means this angle. Okay, so we will calculate how much is this angle. Alright, okay, so before we calculate this angle, we will first find this angle, because this angle and this angle are angles in the same segment BC. Right, so from BC we have got BAC and BEC, and both of them will be equal. Alright, so we have BAC, because we know that ABC and we know ACB. So if we know this and this, we know how much is this. Using sum of the interior angles of a triangle will be 180 degree. Alright, so we have BAC equals to 180 minus 76 plus 76. I am removing these two from 180 in order to get this angle. So this angle turns out to be 28 degree. Okay, so this is 28 degree. Now as I said, BEC and BAC both are angles in the same segment. Okay, and BAC is 28 degree, so that's why BEC will also be equals to 28 degree. Alright, so this will be the last problem for the day. Thank you very much.